Hello guys, so today we have Leetcode number 15 and it is threesome. It's very similar to problems that you may have solved beforehand. It's like twosome or twosome 2 where the input array is already sorted. So I would recommend doing this problem before you attempt this problem. So it says, given an integer array nums, return all triplets nums I, nums j, nums k such that I does not equal j, I does not equal k, and j does not equal k. And nums I plus nums j plus nums k equals 0. Notice that the solution set must not contain duplicate triplets. So you can see in this input, we have a nums. The list is a -1, 0, 1, 2, -1, -4. And of course, you can see that there's two outputs that are unique. The first being -1, -1, 2. As you can see, the sums is 0. -1, 0, and 1. And that is 0 as well. So it's referring to I does not equal j, and I does not equal k, and j does not equal k. So what it's saying that it just does not want the indexes to interfere with each other. And we also, a key thing is to keep it unique. So let's tackle this problem with the same input that we have right here. Okay, so let's see, we have -1, 0, 1, 2, 0, 1, 2, -1, -4. Alright, so to solve this problem, you can do two-pointer, which is the approach I will be showing you guys. You can also do it with the hash map, but basically we'll run a for loop, and the for loop will start at this index right here. And then the two-pointer starts at where after where the pointer is. So you're going to have a left and right pointer right here, basically. And you move the left and right pointer very similar to twosome, 2. You move it based on the sum. If the sum, oh, I forgot to tell you guys, you should sort the array as well. To sort the array, you just do nums.sort, and it'll look like, let's see, 0, it'll look like -4, -1, -1. So let's cross these out. 0, 1, and 2. Right? So that's what this array was, but we're sorting it. You want to sort it because it'll be a lot easier. The time complexity is n log n. By the way, the most efficient solution that I have found or tried myself is O of n squared. And the memory is O of n, I believe, because sorting it does take a little bit of memory depending on what type of libraries you use. But basically, you can just start on the first index right here. This would be where the for loop starts, and then let's call it I. The two-pointer starts at right after where I is, so I plus 1. So you're gonna have a left pointer and then a right pointer at the very end. Okay, and basically the answer will be, so basically it's gonna move based on the sum, right? So you're gonna have a total sum, and this will be -4 minus 1 plus 2, and you can see that it's -3. And -3 is less than 0, so you want to increase the value of the sum, and you'll move the left pointer over by 1. And that's basically what you're going to be doing. And to make sure that there's no duplicates, you're going to have an if statement that will check if I is greater than 0. And just for instance, if I is greater than 0 and I minus 1 does not equal to each other, so let's say I was right here and I minus 1 is not equal to each other, it will just continue in the loop. So it won't do anything. It will just continue to the next iteration. And that's basically what we're going to implement. But I'll show you a better example of how this will work. Let's do this again. So like I said, you're going to have a for loop. That for loop is we're going to call it I. That's the index. You're going to have two pointers after the for loop index. It'll be left and right. And then we're gonna add these three values up in the sum. So you see -4, -4 plus -1 plus 2. And you can see this is -3. Since -3 is less than 0 and we sorted the array, all you have to do is move the left pointer, because we're trying to get to hit 0, right? All you have to do is move the left pointer to the right, and that will like increase it. Like logically it'll increase it because we're sorting the array. And as you can see, we're entering another like -1. So it'll be -3 is less than 0 as well. And then you'll move it over again since it is still less than. And then you're gonna have 0 plus -4 and 2. So you're gonna have -2 is still less than 0, right? And then you shift it over again because it's still less than. You're gonna have -4 plus 1 plus 2, and you're gonna have -1 is less than 0. You can see in this you didn't find a triplet because of course we didn't hit zeros yet. So the I will then move over 1. I will start here now, and left and right will be right here. So you have -1 plus -1 plus 2. And of course, you can see that there's a triplet right here, and then 0 equals 0. You're going to have a variable called result. And then all you have to do is just append these triplets onto the result and then return it at the end. But this loop will keep going until it runs through the whole array. And next, we're going to find the next triplet, right? So right. Okay. So basically, this is going to be, it's going to start over here now. Oh, but like we have an if statement, right? We have an if statement that compares if I is greater than 0 and nums of I equals nums of I. If you see this, you're just going to want to continue, and I would just skip over here. And that's basically what will happen. You're going to have a left and right. So you see, you're going to have a 0 plus 1 plus 2 now. And, oh, sorry, I'm wrong about that. Right. So you're going to have a I, a left, and a right. Just ignore what I said earlier. And basically, it's going to move over 1. Just like I said, just to make sure, -1, 0, 1. Yeah, okay. Yeah, so you're going to have I right here, left, and then you're going to have right. You see, I is equal to, you see I plus L plus R. It'll be -1 plus 0 plus 2, and that'll be 1, right? And you see 1 is greater than 0, so you're going to want to decrement the right pointer. And when you do that, you find the last unique triplet. And that's basically what we're going to do. It's kind of hard for me to explain, but hopefully the code will look a lot better. But like I said, first you're going to start by sorting the input, the list. And to do that, you just do nums.sort. This is n log n. And sorting the array, the list. You're going to have a result equal to an empty list. This will be what you will be returning based on the appends, right? Okay, so you're gonna do for I, A, and enumerate nums. And basically this is the first value is the index and A is the value, right? And we're gonna make sure I is not at first and does not equal to the value before it. And basically this condition checks and makes sure that there's no duplicates involved. And to do that, you would, if I is greater than 0 and nums of I and A equals nums of I minus 1. So you're comparing the current index's value with the one before it. If that happens, you can just continue. You're gonna have a while loop now for the 2 pointers. So while left, while loop for left and right pointer, right? So like I said earlier, you're gonna want to have the left pointer. You're gonna have the left pointer 1 ahead of where I is, so where the current for loop's index is at. So you do I plus 1, right? And then you're gonna have right to be the at the end. To do that, you do length of nums minus 1. And then you do while left is less than right, just to make sure left and right doesn't intersect each other. This loop will only run if that's true. You're gonna want to have a running total, just as similar as 2 sum 2. When you're doing a 2 sum 2, right? You had a total sum, and then you just compared the left and right values if it equal to the target. This is kind of similar to what we're doing. So you make a total equal to A, which is the current index's element value, and then nums of left plus nums of right. This should make sense because it is doing what this was doing right here. And just to make sure you guys are on track, this is initializing the left and right pointers are initializing one after this. And this is the current for loops, and I is the current for loops index. Okay. So now we want to just move the left and right pointers based on a condition. And that condition is if the total is less than 0 or if it's greater than 0. So if the total is less than 0, you're gonna, oh, you need F's, oops. If the total is less than 0, right, you're gonna want to increase increment the left pointer, because that will just, like, logically it'll increase because, like, we're sorting the input array, right? Because -1, because I explained it earlier, but basically -4, it'll increase if you just move one over, just like that, right? LF total is greater than 0. You just want to decrement it, because you don't want the total to be, so the total is greater than, so let's say if 3 was greater than 0, all you have to do is move the right pointer 1 left, because then it would decrease the value itself. And else, so this else statement is where if the total equals 0, all you have to do is just append it to the result list we made. And all you have to do is A, nums of left, nums of right, nums of right, right? And you're going to want to be able to shift to move your increment your left and right pointers, right? Because once you append it, you want it to still continue after to find all the unique triplets. So you just do left plus equal 1. And while nums of left equals nums of right. So this will remove the duplicates, because you don't want nums of left to be the same value as nums of right. All you have to do is just increment the left pointer and then return the result. I explained this pretty bad, but this is the general answer for how to solve it. Let's see if it works. See if there's any errors, and it works. And like I said, the time complexity, oh, it doesn't work. Okay, let's see what I did wrong here. So We sorted the array, we made a list, and then we made a condition if I is greater than 0 and a equals nums I minus 1, continue. Left, right equal I plus 1, length of nums minus 1, while left is less than right. While left is less than right, total a plus nums left is right. If total is less than 0, left plus equal 1, LF total is greater than 0, right minus equal 1, else. Result dot append a nums are left, nums are right, while nums are left equals oh, I see what it did. You want to compare it to the index right before it, so there's no duplicates. So nums are left and nums are left minus 1. Right, and that should work. There we go. Time complexity was what is n log n. N log n plus n squared. Right? But of course, you know that this would cancel out to just be n squared. Memory would just be O of n, I believe. Depending on what you use, but because sorting does take some memory usage. But yeah. Oh yeah, we already submitted. But that's a general solution.